Hello, welcome to this lightning talk. It's Theia Observability and Lessons Learned for your application. So I want to be very clear. I squeezed 20 minutes of information in 10 minutes. You're very welcome, but questions will be at the end. So I'm going to skip through a bit of the about me. Just know that I am the Ericsson product owner of Eclipse Theia, LTTNG, Eclipse Trace Compass. I work closely with academia, and I have the luxury of being on the board of directors for the Eclipse Foundation. Now, the basic problem statement that we have is that we want to improve Theia's general performance. How can we go about doing this? Well, the objective for you in this talk is that we want to solve a performance problem systematically, and we want to show you how to do it like we did in Theia. So please listen to this talk with your applications in mind. Now, some of you may know from the military or other places the OODA loop, as in observe, orient, decide, and act. This is the troubleshooting cycle. It's very similar. You collect your data, you observe your data, you find your issue, you identify the issue, and then you fix the issue. Something very important with these cycles, you need to know how to get in. So the step 0, pick where to start. And we are starting with instrumenting the start time of Theia. And by we, I mean that there were some excellent contributions by Christian Damu, EclipseSource, Tobias, and STMicro Electronics. So thank you guys. And once we have that data, we do observation. Once again, this was done by other people, and I'm very grateful that it was done. You can see the performance. The total time of performance has improved dramatically already. And this is a very good way of going. You basically have the observations and you see the performance progress. By the way, high time, if the line is high, that means that your time consumed is high. That means things are slower. You want a low bar. So we hit a little problem, though. This is a classic toothpaste problem. You have your sweet, sweet performance toothpaste in the tube, and you squeeze the middle. You got the big optimization out. Now you have to start getting more methodical about how to get the rest of that performance toothpaste out of the tube. So what we needed to do was take these measurements and dive deeper. We divide and conquer. The good news is that the measurements that were done were a lot better than what was being displayed. And we could break it down into some more fine-grained information. This fine-grained information can be visualized by either Chromium tracing or Eclipse Trace Compass. Now you're going to have the question. Should you use Chromium tracing, Trace Compass, or both? My answer is both. Chromium, it's easy to open. Pretty much everyone has it, and it solves most problems. Trace Compass is a custom trace visualization tool, and it goes much more in depth, and it's much more customized. It can handle a lot of things that Chromium won't yet, as far as I know. Now, I want to do a shout out to academia. I have the privilege of working with Polytechnique Montreal, and Fateme Daneshkar has contributed a differential flame graph. So what happened was that we were able to take two runs, a good one and a bad one, and compare them. And with that, we were able to see that our dominators had a 25% improvement done so far. This is excellent, excellent news. So if we want to look at it a little more in detail, we took some flame graphs. Flame graphs are the aggregation of your call stack over time. It's a weighted tree. And so you have your first run, the bottom one, which is showing the original time, and the second one on top, which is faster. That is about 1 month later. And the more astute of you will notice that Start Plugins has been accelerated by 25%, as shown in the previous picture. This does lead to a problem, though. When we look at our call stack over time, we'll notice that we have our instrumentation at the very beginning. In the middle, there's the front end. And then at the back end, or at the very end, you have your backend data. And when you're looking at your total execution time, you're looking from the very first event to the last one. So you'll see that there's missing data. What does that mean? We need to instrument the missing data. And if you look, I'm going to go back, you will see that the data, the missing data, is taking about 50% of the new and improved time, which means that your 25% performance improvement actually can go down significantly. So what is the takeaway? And this, please follow for your application. Instrumentation is an iterative process. EclipseSource and Christian did an amazing job. But if they managed to integrate all of that, it would have been a monumental waste. You start, then you see where your gaps are, and you start filling those gaps. The end-to-end test suite is great at showing overall performance. But you do need to dive deeper, and performance tools do exist. Your data is probably already available, and you just need to figure out how to massage it properly. We have contributed a script to help on that front too. And the important part here is that we can work together. If you have questions on performance, on how to make your tool run faster or your program run faster, don't hesitate to reach out to the community. So again, the takeaway here, this is a general purpose process. You can make it work with other applications. And I wanted to be very selfish and announce a personal challenge. If I were to push something similar in terms of instrumentation to Eclipse OpenVSX, think I could get some reviews? I would love to see this kind of systematic methodology applied on that front too. So if you want to try it yourself, I have all the links here. When the YouTube is up, I will copy these also into the YouTube comment section. I hope to see you soon. Please reach out to us. Oh, by the way, we have a YouTube page, so you'll find the information there too. Thank you very much. Are there questions? So there are apparently no questions. I have time to do a quick live demo of Trace Compass showing the data, if that's interesting. Let's do it. Thank you very much. Now, if you look here, this is the differential execution chart that has been shown, that has been developed by École Polytechnique. You'll see that here, Start Plugins has been improved by 27%. Reveal Shell has been improved by 17%, and the front end has been improved by 13%. Once again, if you go look at your flame graph with this data, and I'm sorry, I know that the data is a little small. I have a high-res monitor. If you look, you will see that Reveal Shell, which is in the flame graph, is being pushed later because it's taking more time than, for example, Start Plugins. Now, Start Plugins is the one that has the biggest gains. And once again, if we go to our flame chart, which is showing our call stack over time, we can see, for example, here, this section is uninstrumented. This is where we need to add more instrumentation. We also have a smaller section here. If we look at the bottom here, this is 1 second of unknown. This, on the other hand, is 7 seconds. So I would definitely apply my efforts here if we were to iterate. That is pretty much what I wanted to show on that side. Are there questions now? Are there any plans to make Trace Compass an online tool? That is an excellent question. Yes. Now, Trace Compass already is a Theia plugin. It is available within CDT Cloud. However, we are also making it a VS Code plugin so that it can work better in Theia, because that way we can drag it out of the windows. And honestly, it's a very graphics-rich feature, so we do want to bring it out of the code editor block so that you can have a little bit of separation of concerns. So yes, it's in the plans. Yes, it's demoable. Go to CDT Cloud or try Theia Online, Theia ID. Go drag down to CGT Cloud, and you'll have a demo already. These features will be available too. Another question. Trace Compass looks like a tool to make postmortem analysis. Is there anything planned to make it an on-the-fly trace tool? Now, Trace Compass, there have been pushes to make it online. This is a difficult problem because we're working on the nanosecond level. So imagine playing Dance Dance Revolution or a rhythm game at the nanosecond, getting all that data coming in. We need to think about that carefully. We have discussions, but there's nothing concrete or code yet. Are there any other questions? If not, I fit 20 minutes of talk into 10 minutes. Thank you very much.